here we go, 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 here we go.
Hello and welcome to another episode of Containers from the Couch. I've been doing this for about a year and I never get tired of that theme song. I don't know why, it's really catchy. So, hey folks, my name is Jeremy Cowan. Joining me today is Jimmy Ray over there.
Hello.
He's going to be our other host. And we've got a couple of guests here from the GuardDuty team. Would you guys introduce yourselves?
Sure. Thanks, Jeremy. I can get started. So, hi, everyone. Thank you for joining. I'm Amit Megiddo, lead product management for Amazon GuardDuty, our AWS threat detection service. And I've been doing that now for over 5 years.
Great.
Thanks, Amit. Thanks, Jeremy. Hi, everyone. I'm Mohammad Wasiq. I'm a principal security engineer with Amazon GuardDuty.
Great. And today we're going to be talking about runtime monitoring with GuardDuty for EKS. And I thought we'd start with an overview of GuardDuty. Amit, can you explain what GuardDuty is and what problems it's trying to solve?
Sure. So the goal of GuardDuty is really to help our customers better protect their AWS environment. A lot of built-in security features and controls in AWS, but still can be a high-value target for malicious actors to target AWS accounts and workloads in our customers. And GuardDuty is there to help you detect and give you early signal of when that potentially can happen. So a threat detection service that's been in market now for over 5 years with tens of thousands of customers, including almost all of our top 2,000, top 100 AWS customers, and helping protect them. The way it works is big data analytics. We ingest a lot of different log sources. It could be your VPC flow logs, all of your network traffic, DNS requests coming from your instances, CloudTrail, so off the control plane API operations, the S3 data plane, so access to actual data stored in S3, and continuing to expand. Last year we were here, all of us together, doing this when we expanded to also monitor the EKS control plane through the Kubernetes audit logs. Recently expanded also to look at database threat detection with RDS and Aurora. And all of these logs pass through our threat detection engines. We apply different mechanisms, machine learning models, threat intelligence from partners and our own homegrown threat intelligence, and different heuristics to process, analyze these logs and detect threats. And out the other end come security findings, alerts that our customers operationalize as part of their security operations and act on to help mitigate these threats early on.
Now, you briefly mentioned the Kubernetes audit logs. That was introduced last year, as you said. And we have this new solution for runtime monitoring. Can you explain the differences between these two offerings?
Yeah, so all of this is really part of a very deep focus we have here on container security. We know containers, better than all of us, the broad adoption and the big benefits of using containers and specifically the cloud environments. And we want to offer the best levels of security for these container workloads. So last year, we added visibility to the audit logs. It's all the Kubernetes API control plane at the cluster level. We've had good success with that and a lot of customers using that to protect their EKS workloads. So it could alert you on configuration changes to your Kubernetes or EKS workloads at the cluster level. But we've been hearing from customers that they want us to go even deeper on container security and get to the deepest levels of visibility required for security. And that's what's going on inside the containers themselves at runtime. What are the processes that are running? What are the network connections that they're making? What files are being loaded or downloaded onto the containers during runtime? And that's really looking at that system level event visibility is the deepest level of visibility you can have for security. And we knew we had to get there. I'll also add that a big benefit of that is that we can now offer container specific context in our findings. So previously, perhaps we tell you that there was an EC2 instance in your account that was communicating with a known threat actor, malware command and control server. And the customer maybe would go look at that finding, start to investigate, find out that EC2 instance was used for EKS workloads, and it could have dozens, hundreds of containers running on it. And going through that process of identifying the specific pod and container that was exhibiting that behavior was very challenging. And our findings didn't have that level of visibility through the VPC flow logs or DNS. And now with this new solution, we get that level of visibility. So it provides that specific container, specific pod with all the relevant context on the behavior and activity to help customers quickly investigate and respond to these type of threats.
So with this new basically agents, right? GuardDuty agent, running locally on nodes. This builds on or creates a defense in depth strategy, right? So we've started out with GuardDuty looking at the audit logs. Now we're looking at the nodes with a new functionality. So we have this layered approach to security, this defense in depth that helps us, build upon and reduces the chances of us missing something. Something that may not show up in the logs may also be picked up by the agent. And then, as we talk about later in the demo, there's also the opportunity to correlate multiple streams of information, right? So it's really exciting for me to see this.
Yeah,
definitely.
Yeah, totally. So Amit, you mentioned threat detection earlier. What sort of threats do you see customers being able to detect with GuardDuty?
Vasik, you want to take this one?
So with GuardDuty in general, I'll start with generally speaking about GuardDuty a little bit, and then we can quickly move on to the new runtime protection that we are talking about. So with GuardDuty in general, primarily we focus on few different things. We protect a few different resources, right? So the first and foremost is the EC2 instances, right? So we have runtime protections based on flow logs, DNS logs, and now using agent-based runtime logs as well. So these detections are aimed at identifying any attack against your EC2 instances, or if an EC2 instance is compromised, then these detections aim to detect that compromise. And then we also protect and monitor, primarily monitor your AWS resources, like AWS entities in your AWS account by monitoring the CloudTrail logs, right? So any API activity using your IAM entities, IAM roles, and IAM users, we monitor all that 24/7, and then we apply some simple stateless rules, lots of stateful rules, and very sophisticated machine learning to those logs to identify any attacks on your AWS resources. So that's another thing. The third thing is related to CloudTrail logs. We have protection for S3 S3 buckets or data level operations on your S3 buckets. For example, somebody accessing or downloading your S3 bucket and so on. Then we have, as we have already talked about, Kubernetes audit logs. And the new things that we have another new area that we have added, as Amit also talked about, is the RDS protection now. Now we are doubling down on the EKS and Kubernetes protection, primarily on EKS right now. So as you said, we have audit logs, and now we have agent-based runtime monitoring on your EKS workloads as well. So with this runtime monitoring, we have an agent which is built using the eBPF technology, Linux eBPF technology. So it has a kernel probe which is sitting inside the kernel, and then it is capturing all the required events in the kernel. So that's it's difficult to bypass for an attacker unless they already have the root level access to the node.
Now, can you talk a little about why we chose eBPF instead of, say, like writing a kernel module?
Yeah, because of the safety. The number one reason was safety, and the number two reason was the velocity of development and rolling out the solution, right? So you have to be much more careful when you are developing the kernel module, because your kernel module is running unprotected inside the kernel, and there is a high likelihood if there's a bug in your kernel module, then it is going to crash the customer kernel or customer's node. With eBPF, you are covered for that by default, right? Because eBPF have lots of protections built in. It first of all validates your code before running it, and then it has lots of constraints. Like, for example, you cannot have unbounded loops in eBPF, so you cannot have something like while one, right? So you cannot really hang the kernel if you're using eBPF. So, and the third reason was that it is much more acceptable to customers. That customers trust. It seems like customers trust eBPF solutions more than kernel module based solutions these days, and primarily because of the safety reasons.
Yeah.
Especially in the CNCF community.
I wanna add also, part of this is our focus here. So agents can sometimes in the security space can be a little bit of a scary word, the implications of running them and the overhead and the complexity. And part of the design decisions here were really to start really lightweight. So call it an agent. It's a daemon set, and that was designed to be lightweight. It focuses only on collecting telemetry and doing some basic decoration, and then just sending the events to the GuardDuty backend, where all of the heavy load of processing, analyzing, applying the models happens. And this allows this to really reduce the overhead and the complexity of running these kind of solutions. I think also tying to something Wasik mentioned on the unless the malicious actor has root access, and also tying back to Jimmy's comment on defense in depth. So in addition to running this security agent and having this level of visibility, we also continue to process the VPC flow logs and DNS requests from the node level. And in the case where there is a malicious actor that potentially tampers with the security agent and we lose that level of visibility, we'll still have the level of visibility to the flow logs and the DNS requests, so that those can't be tampered by malicious actors. This happens on the back end, out of band. So we'll still have some signal even in these cases that I think is quite unique. We know that there's also cost implications of continuing to process both. So GuardDuty customers that deploy this new EKS runtime solution will continue processing the flow logs for you at no additional cost. We'll eat that up so you can enjoy the benefits of both.
So I really like the idea. To me, it sounds like, choosing eBPF has allowed us to leverage what I would call existing guardrails, so to speak, such that, we're using those eBPF guardrails instead of using a kernel module. So, I'm not saying it's a sandbox, but it basically puts up a set of guardrails, that we can go between and do the things we know we need to do without compromising a customer's, operating system, their host. So, I mean, to me, you're getting the best of both worlds. We talked about defense in depth, but we also, the way that we made a decision to go this route makes it less intrusive. And let's face it, agent adoption does get a little tricky sometimes. So, these are some good decisions here that I think will help adoption of this particular solution.
Yeah, and I think we'll see here very shortly how easy it is to get started with GuardDuty. That's probably a perfect segue into the demo. Wazik, you have a demo prepared for us, right?
Yeah, we both have a demo. There are two parts of the demo.
Okay.
Right. So in the first part, we are going to simulate some like realistic kind of attacks which we usually see on EC2 instances, and then we'll see what type of we'll discuss what type of detections that you could expect through the solution for these types of attacks.
Okay.
And the second part of the demo is we are going to demonstrate how easy it is to enable it. Like it's pretty much one click. It is basically one click enablement, and it could be done at AWS org level, so you don't have to do it on individual accounts. You can enable it on all of your member accounts. So this is what we are going to demo.
Okay. Anytime you're ready, you can put up
Yeah.
the screen.
So I can start sharing my screen.
I'm not seeing it yet. There we go.
Yeah, so imagine a scenario that I leaked out the credential of my Kubernetes cluster. So I leaked out it to my code, and that code was published to GitHub. And from that GitHub repository, an attacker was able to compromise or steal my Kubernetes credentials. Now the attacker, naturally, once they have the Kubernetes credentials, they can do several things. They can connect to the API's endpoint of my Kubernetes cluster. They can create new pods. They can exec into or connect to the existing pods that I'm running, right? So here in the first scenario, what I'm going to simulate is that the attacker now they have the credentials, so they try to exec into one of the pods that I already have on my cluster.
Okay. Can I ask you to enlarge your font a little so that it's easier for the folks watching to read?
Sure. You are seeing my
I can see your terminal window. Yeah.
Okay,
I was just
you
wondering if
can
you can
see
make
me.
the font a little bigger. Yeah.
Definitely. Yeah, change settings, appearance. How about this?
Yeah, that's a little better. Yeah.
Yeah. So I'm simulating the attacker, and the attacker used kubectl. They have already set up the credentials that they stole. Now they use the kubectl to connect to my pod, one of the pods which is running on my Kubernetes cluster. Now they are connected. Now they can, so pod is pretty much like a compute resource, so they can do several things on the pod. Like they can, for example, you do crypto mining on the pod. They can also steal any credentials or data which is available on the pod and so on. So what I'm going to simulate is that the attacker first downloads a crypto miner on this pod. I'll just copy paste the command because I did not memorize the path of the miner. Okay, so the crypto miner is downloaded. So I can make it executable now. And then now I, as an attacker, execute it. Right. So now I'm doing the crypto mining on this pod. So another thing, like while we are doing the crypto mining on the other window,
And we think this would be completely transparent to like the cluster operator. They wouldn't necessarily be aware that a person was running a crypto miner ordinarily, right? It doesn't affect the other workload that's running.
They don't have the runtime logs, so that they wouldn't know. The only thing that they could see from the audit logs would be the exec when somebody execs into the pod, right? And there are so many exec requests. Typically, you just pretty much neglect those. But we have Kubernetes or EKS audit log protection as well. So though that side of the protection monitors the audit log as well. So there's a heavy chance, or there's a big chance that the initial exec by the attacker into the pod could be caught or could be detected by audit log based detections.
Right. But that isn't the only way that they get access to a pod. They could like start a reverse shell, or there are probably numerous ways that they can actually get into a pod.
Yeah. So now they have, once they have got into the pod, what they could do, they can also, like, maybe the credential is a temporary credential. I mean, it might expire in an hour or a few minutes or so. So they want to persist. I mean, one way of persisting is to start a reverse shell. They can start the reverse shell so that they can submit command to my pod and do whatever they want for a longer term, right? So here I'm going to just simulate a simple reverse shell here. I have a script which performs a reverse shell. Yeah. Okay. So these were the attack simulations that I have. Now, what we can do while we are waiting for the findings, we can move on to the second part of the demo, which is to show how easy the enablement is. Right.
Okay.
So here I'm showing my GuardDuty console. Hopefully, I'm still logged in. Yeah. So the account is being managed by an organization. So I am a member account, and the Amit is the org admin. So I'm the member of his org. So that's why I cannot see the protection, like the configuration here. But
and when you say org, you're specifically referring to AWS organizations.
Yeah, and then GuardDuty also has a concept.
Okay.
Yeah, so specifically, I'm not the org admin. I'm the GuardDuty admin for the org. So through GuardDuty is integrated with AWS organizations, where you can delegate through the org admin. You can delegate a GuardDuty admin for the org, and that allows that GuardDuty account to manage GuardDuty for the organization, ensure it's enabled on all existing accounts, new accounts, view the findings for all accounts in the organization, and manage them. I'll start sharing my screen, Jeremy.
Yep.
Yeah, one thing. Let me show one thing before you share, Amit.
Mm-hmm.
So as I showed that I'm a member. This is a member account, and I think we also briefly touched upon, like, we have implemented this agent for EKS as an EKS add-on, and the add-on deploys the agent on all the nodes as daemon set, right? So when GuardDuty protection, like EKS runtime protection or monitoring, is enabled in all of your clusters, you can go to your EKS clusters. Here I am in my EKS cluster, which is the name of the cluster is Wasir test here. And you should be able to go to the add-on tab, and you should see the Amazon GuardDuty add-on here, which I don't see, which basically indirectly indicates that my account is not enabled yet. Amit, please take over and you can enable now.
Okay. Amit, I think you might have to share your screen. Oh, no, there it is. I will add it to the foreground.
Okay. Yeah. So here I am in my GuardDuty account. As mentioned, I'm the GuardDuty administrator for my organization. And I see here that under EKS protection, something new, I manage protection. And EKS protection includes two things. It includes the Kubernetes, the audit log monitoring, as well as the new runtime monitoring. I can also see here that I can view the coverage, the runtime coverage for my organization, and I see that there's a cluster in Wasik's account that is unhealthy. It's not currently protected by GuardDuty. Here under the configurations, I can manage the settings for my own account, which I already have enabled for audit log monitoring, as well as for runtime monitoring. As you can see, have still 24 days remaining on my free trial. So any accounts, whether you're already using GuardDuty or new to GuardDuty, this feature comes with a 30-day free trial. And during the free trial, you can also go to the usage page up here and to the left, and you'll see a cost estimate for how much it'll cost you post-free trial based on actual usage. I'll now enable it for my organization. So click here. Actually, one step before. This is where I can enable it for all accounts in my organization. As we can see here, I can also choose to go to my accounts page of my member accounts and organizations. And from here, I can manage it for individual accounts as well. So I can decide that, maybe I'm trying this out and I want to see how this performs, and I want to choose two of my test accounts initially. So I'll select my two test non-production accounts, and here I'll manage enable EKS runtime monitoring just for these two accounts. But for now, I'll go ahead and enable it for our organization. So I click edit here, and I see that there's a number of configurations that are set here by default. The first is to enable the EKS audit log monitoring for the organization. I can choose whether I want to have both or just one or the other. Recommended to use both, as well as the new EKS runtime monitoring. And there is an additional configuration under the runtime monitoring, which is to manage agents automatically. I think this is where a lot of the magic happens. We've been hearing now for a long while for customers that they need this level of visibility and security coverage for their containers. But traditionally, this comes with a lot of overhead and complexity to ensure these agents are deployed across, I have 17 accounts here, but often hundreds or thousands of AWS accounts, dozens, hundreds or thousands of EKS clusters, tens of thousands or hundreds of thousands of EC2 nodes that are in these clusters, new nodes spinning up and down, new clusters spinning up and down, new accounts spinning up and down. it's there's a lot going on there, and for the security team to have to manage that, where traditionally it would require high involvement and back and forth with the operators and application or DevOps teams. Customers have been telling us that's a big challenge for them. And
yeah, I wanted to get a couple of questions in here from the chat, and I think it's related to what you're talking about now. So the first question is from Amjad. He says, are we saying that instead of having GuardDuty deployed in an AWS account, we can deploy it in our central security or master payer account to manage all AWS accounts? And so I think this is related to what you were saying about how you enable it at the organizational level.
Yes, it's recommended to not enable it in the master payer account and or to not, it's recommended to enable it in that account. It's an important account to protect, but to not use that account as your GuardDuty admin account, but to delegate administration to your central security account. So yes, you can manage GuardDuty centrally for the entire organization from one account. Yes.
And then are all the findings aggregated to a central account?
Yes, findings from all members are aggregated to the central account. Yes.
Okay, and then Amjad has another question. He wants to know how costly this implementation is. You did say that it's relatively low cost, but can you give folks a sense of the cost model for GuardDuty?
So this is aligned to the way that to your EKS costs. So in EKS, you pay for the compute hours, and here as well, you pay for the compute hours that GuardDuty is protecting. So we monitor how many hours the agent was active and working on a node. We use
looks like Amit froze there.
The number, the hours, vCPU hours protected. There's public pricing available. There's a tiered pricing. So if you're a large customer with a large EKS deployment, you'll quickly work yourself down or up to the higher discount tiers. And really, we remove the operational complexity to deploy this. And our aim with pricing is also to, as much as possible, reduce that as a friction point and help customers just go all in organization wide and get this important level of coverage.
Yeah. Okay. The questions are coming in fast and furious. I want to get to a few others here. So there's a question from Ajav. Hopefully I'm pronouncing that correctly. Will it search the already generated logs on Wazeek's cluster and recognize the crypto mining? And does it work backwards? I'm not totally sure what that means. Wazeek, can you try to answer that?
I got an idea what they're trying to ask. It's purely real time, right? So we are sitting inside the kernel and collecting system call events in real time. The agent collects those events and send those back to the backend in real time as the attacks are happening. It can, of course, on the backend, it can trace the activity and maintain the state of a certain activity. We can do that, but the agent does not look for retroactive, or it does not at this moment analyze the static logs or existing logs on your EC2 instance. It's primarily,
So in that case, if Wazeek's account isn't enabled yet, there won't be a detection for what we previously saw him do. And in a lot of, specifically with the crypto mining use case, that usually has repeated activity where we see repeated connections, IP connections made to the mining pool or DNS requests. And usually these type of activities are ongoing. So if there's already mining activity going on your cluster or one of your nodes in it, there's a good chance that GuardDuty will pick it up once enabled.
Okay. Sorry.
Oh, sorry.
I was going to say there's another question in there. So this is from Kritsyik hopefully I'm pronouncing that correctly. I apologize if I'm butchering your name. Are there logs for EKS GuardDuty? So like if you were to run like kubectl logs and then specify a daemon set pod for GuardDuty, would there be logs? And what would you see?
So the agent is running as a daemon set, right? So which is a Kubernetes deployment resource,
Right.
or a Kubernetes workload resource. And then whatever Kubernetes supports in general for workload resources will be available to the cluster admin.
Okay, great. I just wanted to quickly return to what you were talking about earlier, Amit, about enabling GuardDuty in different clusters. If, say, an attacker were to disable GuardDuty in a particular cluster, would the health status of it change within the GuardDuty console?
So it won't be disabling GuardDuty in the cluster. It could be tampering with the GuardDuty security agent in that cluster. And in that case, yes, you will see that the health status will change. We saw the health status before in the UI. In addition to that, we also generate Amazon EventBridge events on status changes, and you can subscribe to or automate these events through SNS or integrate it with Slack or PagerDuty or Jira tickets, etc. And use that to get a push notification on a change of status. So if a cluster goes from healthy to unhealthy, you don't need to log into the GuardDuty console each time and refresh to find that out, but you can get an alert on it into your regular workflow tooling.
That's really nice. And this way of installing the agent is super convenient, but I imagine that there are going to be folks who may want to install it manually. Is there an option to do that?
There is. So, and maybe I'll continue with the demo.
Sure,
demo is part of that. So right now I have this configuration set to manage agents automatically, which will result in all existing and new clusters across all 17 accounts in my organization. GuardDuty automatically enabling the EKS add-on, which results in the agent installation as well as creating all the required resources in the account. So there's a VPC endpoint that's required in order to send the events to GuardDuty, and GuardDuty manages all that for you. So it's as easy as clicking save changes here and being told that this will result in the agent being deployed and updated on the clusters and the enable of the audit logs. And now this will happen for all 17 accounts in my organization. I can also choose to uncheck this box of the manage agents automatically, in which case it can be managed at a per cluster level, but then it has to be done directly from the account where the cluster is running. And you can go to the EKS console, the add-on section, and just enable the GuardDuty Runtime Monitoring add-on. In addition to that, you'll also have to create the VPC endpoint in the account or in the VPC where the cluster is running. All of that is detailed in the user guide. Now, if I choose to disable EKS Runtime Monitoring, so uncheck this box, it will also result in GuardDuty cleaning up all the resources. So all the agents that were deployed will be removed. All the VPC endpoints will be removed. If you went with the manual enablement and then disable this, then you will also have to manually remove these resources.
So I understand the user experience. If I turn this on at the central security organization level account, the user experience, it will go out and add the agents to new and existing clusters, correct? Okay.
Yeah,
Yeah.
so
Mo-
that's all that
Moon
needs to
existing
be done
clusters
for
will
the organization.
And then, and the VPC endpoint plumbing, all of that is done for you in the background if you're doing it through an automated way, right?
Yeah.
Pressing that button is quite literally the only thing you need to do.
Okay. Yeah, that is really easy. So,
Very low
With
friction.
yeah, that again, that's the goal. We wanted to get to this really highest level of security visibility while maintaining the GuardDuty easy on enablement that we know customers love. We hope we managed to do that. Wasik, you want to take
Yeah,
over
sure.
and show it's now enabled in your account?
Just give me a second. Yeah, so here I'm again on my EKS console. Let me refresh my cluster. Okay, so I'm logged logged out, unfortunately, so I'll have to log back again. So the cluster was in US West 2.
And while Wazik is getting ready here, another question came in from Jonathan. He's asking whether there's a plan for upgrading the cluster, say to version 125. Is the agent dependent on the cluster version, or there's no dependency between it and the version of Kubernetes that you're running?
So we have specific versions supported, right? So those versions are listed in the documentation. All the current recent versions are supported.
So essentially, it's just like other add-ons, right? You can go and look at the add-on if you wanted to. You could look at the add-on and see what version of that add-on supported what version of EKS in the background is right.
Yeah. So you may not have to upgrade the agent when you upgrade your cluster. You can continue running the current version until a new version of that agent is released. And if it's enabled at the organization level, and you've clicked the maintenance button, then when a new update is available, it will automatically be deployed to those clusters that are in the organization.
Yes. And otherwise, if you go the manual route, then we'll issue updates when there are updates, and you'll have to go and manually update the version.
So that brings up another question I had for the user experience. Again, setting it up in essentially automatic way, and it automatically gets placed onto the clusters. Would it still show up then as an installed add-on in the EKS clusters?
When you do
Yes.
it manually?
No, automatically.
Yes, I think that's what we're seeing now, right? Wasik, you're now in the account where I enabled it, and we see the add-on is now there. Yeah.
All right.
Yeah. So before I transferred control to Amit, I showed you that there was no add-on in my on my cluster.
Right.
Now after Amit enabled EKS runtime monitoring protection at org level, I'm the member account. I can now see the GuardDuty EKS runtime monitoring add-on in my cluster automatically added for me.
Nice.
So that kind of folds it into the already well-known add-on management that we have built into EKS. So you're taking advantage of that as well, so people can already use that to help get notifications when maybe that add-on is ready to be upgraded, or or there's a new version available, let's say, of that add-on.
Yeah.
You want to go back to the findings? Show the findings.
Yeah. So yeah, let me go back to the finding. Hopefully. So yeah. So I got the findings here. So just to recap what we did. So the attacker, I simulated the attacker, and I exec into one of my pods, and then I downloaded a crypto miner inside the pod or inside the container that pod is running. And then I executed that crypto miner. And the second simulation that I did, I created a reverse shell, right? So there are two activities which we did. One was crypto mining, downloading the miner, and then eventually performing the crypto mining, right? So for that activity, the first one, the mining one, we actually have got three detections here. The first one, Bitcoin tool.b DNS finding. Uh, those of you who are already using GuardDuty, you guys may already be familiar with this. So this is equivalent to our EC2 finding for Bitcoin or crypto mining. And this is based on primarily threat intelligence. So the agent is also capturing DNS request and responses, and then sending those DNS request and responses to GuardDuty backend. And we use those DNS request and responses to the mining pool domain to generate this finding, right? The primary difference that I would like to highlight is that's bad. Sorry for this. Oh, I'm in US West 2. Yeah, so the attacks were simulated on my cluster in US East 1. So the finding should also be in US East 1. So I was talking about this. Is the font okay, Jeremy? Or should I increase the font size?
You're on mute.
Yes, if you could increase it one size bigger, I think that would help a little. There you go. Yep.
Yeah, so I was talking about this Bitcoin tool.b finding, which is equivalent to our EC2 findings. The main difference is that with runtime monitoring, you will get a lot more context here. So with EC2 equivalent of this finding, you only get the instance details, EC2 instance details. But here, you also get like Kubernetes workload details, you get EKS cluster details. So Kubernetes workload here means pod. So you get all the pod details, you got the name of the pod, you got the ID of the pod, and you also got the container level details. So you got the ID of the container, and one of the most important things is when it comes to the container detections, one of the most important things, the image, right? Because you want to identify if your image is vulnerable and which image was attacked or which image was vulnerable so that you could fix and do the root cause analysis. And then again, like EC2 findings, you also have the EC2 instance details here. On top of that, you also get process level details. Like this is the process level details. You get the name of the process, you get the complete executable path of the process. You got the SHA-256 hash of the process is executable, which is very important because if you can take the SHA-256 hash and you can search it on websites like VirusTotals to figure out if it's already a known bad malware, right? And then you also have the PID process IDs. Basically, you will see two different process IDs here. The one is just process ID. So this is the host level process ID. So this is the ID of the process which the host sees, or the host namespace process namespace sees.
Right.
And then you also get the namespace process ID. So namespace process ID is very useful because this is the process ID that you see inside the container, right? So this is the container specific process ID or the process ID in the container's bid namespace.
Yeah, so I was waiting until a person asked about ChatGPT. So Talamir asks, do you have any plans to create a configuration assistant based on GPT-4 or similar AI models, and what would be the pros and cons? I mean, I could definitely see a technology like ChatGPT being used here to help you, identify threats and potentially how best to respond to those. I know that we're approaching our time here, but now might be a good time to talk about futures and what's in store for GuardDuty.
If you just give me a minute, I'll show you
Sure.
some more
Okay.
some more valuable features here, which
Okay.
would be useful to customers. So like this detection is also really useful. Reverse shell, which is a very common exploit technique on Linux workloads. So again, as I said, I simulated a reverse shell there, and we got this reverse shell detection here. Again, like all the context, and then we have the process level details as well. Another important thing in process details is the lineage of the process, which gives you the end-to-end lineage or all the complete tree of the process, including all the ancestors, starting from the parent to grandparent and so on. So you can, at level 1 is the direct parent, which was bash in this case, because I simulated reverse shell using a bash script. Now the second one is also bash because it was just a script and then it was running commands inside. So that's why I have multiple levels of bash here. And then if you see the level 4, it's run C. It's basically indicates that the original process which started the container. So that's why we are here. Like we started the tree from within the container, and then we moved to the host level as well.
Yeah, so I could see this being really useful during incident response, where you have to identify where the attack is coming from, or what resources or pods are impacted by the attack.
Yeah.
Right?
I'll just add, Jeremy, that what we're seeing here, the console view, behind the scenes is the JSON files. We know a lot of customers push these out to other security tooling or workflow tooling. And all of this rich detail that Wasik is showing is available in the JSON itself and can be consumed outside of GuardDuty.
So like I could take, the data that we're seeing here in the findings and send it to, let's say, EventBridge, and then have maybe, something triggered from that to react to what we find here.
So when the finding was generated, it automatically triggered an EventBridge rule already, and you can configure that rule to send that, either to a Lambda function to already do some maybe containment action, or to, again, a Slack notification into Splunk for additional investigations. Yeah.
Good.
So let's talk briefly about what's next for Patrol, or sorry, not Patrol, but EKS Runtime Monitoring. The current iteration is for EKS, but are you also looking at expanding that to other compute services? I know you already have coverage for EC2, but are there plans to offer similar types of monitoring for, say, ECS and Lambda?
So yes, as always here at AWS, it starts from the customer. We listen to our customers and their feedback and what they want, where they want us to take the service, and definitely seeing this level of visibility expand to other compute, other container deployment options we have in AWS. Definitely something that we know our customers want.
That's great. And if folks are interested in learning more about EKS runtime monitoring or getting started, what's the best way for them to do that? You mentioned that there's a 30-day free trial.
Yeah. So 30-day free trial for each.
Oh, Amit, I think you froze. We lost Amit. Wazik, do you want to finish Amit's thoughts here on how to get started?
Yeah, so there is 30-day trial. You can choose an account where you want to enable it. You can auto enable in an account and use it for 30 days for free.
Yeah.
Amit, go ahead.
Yeah, sorry, I'm back. I see what Seek answered in the 30-day. I just wanted on the forward looking to say that our customers that have been using us for several years now know that we continue to iterate. We don't launch a new coverage or something like this and just let it sit and become stale. So you can expect also many new finding types and detection capabilities that leverage this runtime visibility. Our data science team is already researching, applying even more advanced machine learning techniques to these runtime events to detect the highly evasive attacker techniques. So, yeah, so more coverage and more detections coming.
Great. That's exciting. Okay, well, I want to thank our guests, Wazik and Amit, for coming on the show to tell us all about EKS runtime monitoring. Thank you all for joining, and we'll talk to you again soon. Thanks.
Thank you for hosting us.
Thank
Good
you.
stuff.
Absolutely.